In this video, we're going to look at some advanced problems involving arc length and sector area. Before we continue with this video, you need to be able to answer questions like the following. First of all, can you find the area of this triangle using the information given? And secondly, can you find the length of this side of the triangle, again using these bits of information? If you're not sure about how to do those, you need to first go and check out topics G18a and G18b. To quickly recap, what we need are the formulas. Area of the triangle is going to be a half multiplied by a, b, sine capital C, and the cosine rule, which tells us that a squared equals b squared plus c squared minus 2bc cos a. If these don't ring any bells, then this is not the right time for you to be watching this particular video. Here is the question. We've got a circle, we've got a 125-degree angle here, and a sector is given to us, but we've also got this chord and a shaded segment over here. And what we need to do is find the area and the perimeter of that segment. Now let's focus on the area to start with. What we can do is first find the area of the sector, which is this bit here, and then subtract the area of this triangle. If we subtract this triangle's area, we're left with the area of that shaded segment. So let's write that down. Let's start by working out the area of the sector. I'm just going to number this as number 1 to show what we're doing. So the area of the sector is simply going to be 125 360ths of the area of the circle, as we saw in the previous video. So that's 125 360ths multiplied by the area of the circle, which is pi times the radius squared, and in this case the radius is 15. So pi times 15 squared, that's the area of the whole circle, and this bit, this fraction, is the fraction of the circle that makes up this sector. Putting that into my calculator, I get 625 over 8 multiplied by pi, and the units are centimeters squared. Now I'm going to leave this in exact form for now. I'm not going to convert it into a decimal. Next, what I want to do is subtract the area of just this triangle, this white triangle. And I'm going to draw a green outline so you can see clearly what I'm talking about. That's this triangle here. And to find the area of this triangle, we're going to use the formula a half AB sine C. Now let's just remember, this side of the triangle here is 15 centimeters. Now this is a radius of the circle. This is also a radius of the circle. It goes from the center to the circumference. So that means this length is also 15 centimeters. And here we've got two sides and the angle between them. And using the formula that the area of a triangle equals a half AB sine C, we get that the area is going to be a half multiplied by 15 multiplied by 15 multiplied by sine of 125. Putting that into our calculator, we get 92.1546, and I'm going to keep that on my calculator display, even though I'm not going to write it all down here. And I write a ... to show that I'm actually going to use the full value when I work out my final answer. Now remember, the area of the shaded segment, just this bit here, is going to be the area of the whole sector minus the area of the triangle. So we've got the area of the segment, the thing we're looking for, equals 625 over 8 multiplied by pi. And I'm going to subtract this number here. Now, because this is the last calculation I did on my calculator, what I can do is simply press the answer key on my calculator, and this will give me the correct answer. Putting all of that into the calculator, I get 153.282 blah blah blah, some more digits there, and if I had to round that to 2 decimal places, I would get 153.28 centimeters squared. What we've done then is find the area of this shaded segment. It's now time to find the perimeter. The perimeter of this shaded segment is simply the distance all the way around it. And you can see it is made up of 2 parts. We have this straight bit, which is a chord of the circle, and we also have this curved bit, which is an arc of the circle. So let's write that down. Let's focus on the arc length first of all. So the arc length is going to be this particular part of the perimeter, that's here. And to calculate that, we need to spot that again. We're dealing with 125 360ths of the circumference in this case. And remember, the circumference is 2 pi r, so that's 2 times pi times the radius here. And popping that into my calculator, I get 125 over 12 times pi. Secondly, let's look at the chord length. That is this part of the perimeter here. Notice that this chord is actually one of the sides of this triangle. And remember that we know that the length of this side of the triangle is 15 centimeters because it is a radius of the circle. To find the length of this side of the triangle then, we need to use the cosine rule, because we've got 2 sides and the angle between them, and we're looking for the length of the third side. Labelling this up, I'm going to call this side A, so I'm going to use lowercase a, capital A for this angle, and then the other 2 sides are B and C. We don't really need to label the other 2 angles, but I will do so anyway. So we've got angle capital B opposite the side B, and angle capital C opposite side C. Now, substituting all of this into our formula, we get a squared equals 15 squared plus 15 squared minus 2 times 15 times 15 times cos of 125. So I've just used the cosine rule to find a squared in terms of B, C and capital A. I've substituted these values into here. Substituting all of that into my calculator, I get an answer of 708.109 with more decimal places. Now, that is not my final answer. That is a squared. To find a, I need to work out the square root of 708.109. And I'm going to do that by just simply pressing the square root button on my calculator and then the answer button. And that will pop in the most recent answer I'd got, which was 708.109 blah blah blah. That square root works out to be 26.610 with some more decimal places. Now that is just the length of this chord. Remember, we were looking for the perimeter. We needed to add together the arc length and the chord length. So we need to add together this arc length and this chord length down here. Writing that down, we get perimeter equals, and working that out on my calculator, I get 59.335 blah blah blah, lots of decimal places, which to 2 decimal places is 59.34. And don't forget the units. Remember, I was looking for a distance around this shape. That's its perimeter. And we were working in centimeters, which means our answer is 59.34 centimeters to 2 decimal places.